Good afternoon, everyone. My name is Dave Entwistle, Chairman of the IMechE Aerospace Northwest Committee. Today, we have what will be a very interesting human factors introduction from Marcus Madden, from Bain Simmons, which will have an aerospace theme, but human behaviour can have consequences across all walks of life. So this will be useful information for all. Following the presentation, Thurai Rulan, also from the committee, will collate your questions for Marcus to answer. Marcus has over 40 years experience in the aviation industry as a licensed engineer with various official aerospace bodies, and he has worked all over the world for various national flag carriers before joining Bain Simmons. His client experience is extensive, including the European Defence Agency, national aviation authorities, including the UK CAA, UK MAA, Royal Air Force, Royal Navy, BAE Systems, Rolls-Royce, Quinty-Q, British Airways, Indigo, Saab, General Electric, and Pratt & Whitney. So extensive. Marcus has an extensive practical understanding of how to implement safety improvements at all levels within an organisation. Drawing his technical expertise and comprehensive knowledge of human factors and error management systems, Marcus helps senior management teams understand how to practically implement safety performance improvement programs within their organisations. His down-to-earth practical approach and sense of humour, combined with his significant industry experience, ensures clients can gain the maximum value from his input to their programs. So, yeah, Marcus, he knows his onions, basically. So, without further ado, I will bring in Marcus. Just as a note, there is a PDF running at the same time for anybody that's interested. So if you look on your resources tab, there's something called a first system that I think Marcus might tell you about. So just make sure you click on that if you can. Anyway, so I'll hand you over to Marcus and he'll take you through it. Thank you very much, Marcus.
Thanks for that introduction, David. I was impressed by the person you were describing. It was only at the end I realised it was actually me. So, good afternoon, everybody. I'd like to thank IMechE for this opportunity to talk about my passion, which is being a human being. The subtitle of that is getting a group of people to give me a good listening to. I began my aviation career as a mechanic in the Royal Air Force, but have spent the majority of my time as a licensed aircraft maintenance engineer working in civil aviation. 12 years ago, I became a member of the Bain Simmons team, and I'm now in a very fortunate position where my passion and profession are one and the same. We, that's Bain Simmons, are specialists in aviation regulations, compliance, and safety management. We partner with the world's leading civil and defence aviation organisations to improve safety performance. My primary areas of expertise in human factors and event investigation. In the past, I've had the really difficult experience of working on an aircraft that unfortunately has later crashed. And in a couple of cases, tragically, this involved the loss of life. This led me to question my behaviour and actions and those of my colleagues. When I began my career many years ago in the RAF, in the aftermath of close calls and negative events, only rarely was the system held up to scrutiny. We learned to live with and not complain about a lack of support. Initiative and can-do were valued unless they led to failure. Then the talk was of rotten apples, people are only as good as their last job, Things like only bad workmen blamed their tools. Sorry, jump forward a slide there. Human error. The title really, or certainly what I'm going to be talking about, the nub of it is, is human behavior in complex socio-technical systems predictable? Where we interact with complex systems, where we rub up against them. With an improved knowledge of human performance, we've gained a better understanding of how closely the way humans perform is coupled to the effectiveness of our systems. Our physiological and cognitive capabilities and constraints contribute significantly to the safety performance of our complex systems. Humans always contribute to achieving the required output, the one that we wanted, but this may be in spite of the system rather than because of it. Only by understanding our limitations can we design effective systems. Whether it's new technologies, training and equipment, more usable procedures, or the right environment, any safety and efficiency benefits can only be fully realized when they're designed to support the performance of the humans who interact with them. We must make it easy and not problematic to do the right thing. We need to set people up to succeed. In our systems, people may be the source of threats, but are also integral in identifying and managing them. Historically, we focused on outcome, less so on the behaviors that contributed to them. We must accept that humans are fallible, distractible, easily confused, irrational, and given the right kind of stimuli, capable of responding without any real conscious thought. A distraction contributed to this person slipping and falling. I think probably most of us have been there. They, like all of us, have physical and mental limitations. Our focus can be lost or misdirected. We all need sleep to function effectively. We can't all lift heavy weights, leap tall buildings, see in the dark, or operate continuously in stressful situations without our performance degrading. Evolution has given us the means to cope with difficult situations. Fight or flight is an automatic response to threatening situations. It optimizes our body to ward off an anticipated attack. Not so successful for the person in the cartoon, I guess. These automatic responses, whether inbuilt, like fight or flight, or learned, come with pros and cons. We can't usually respond to stressful situations by attacking people or running away. It's kind of frowned upon in the workplace. And if exposed to stress over a long period of time, our physical and mental well-being will start to suffer. So not always a good response. Take, for example, learning to drive. In terms of, responding without thinking. So, when we first learned to drive, it needed a lot of concentration, a lot of mental effort. But now, I'm sure some of you have been driving a fair while. Do you even think about driving the car when you're sat in that seat? If you commute any distance, do you remember the drive to work? Once we've achieved a certain skill level, it allows us to free up cognitive resource, spare capacity. We can carry out familiar tasks with little conscious effort. Minor technical glitch there. We generally, as people, act with the best of intentions. We don't come to work with the aim of getting it wrong, or playing a part in in any form of contribution to an accident. We assess the situation and we take action based on our knowledge of the facts, procedures, and any previous experience. Pictured is a colleague's son in the act of dynamic problem solving. Why he chose to go away, get a camera and take a picture of his son in this situation, I'll have to ask him about this a little later. Within any complex operational environment, I guess you could say in this case a kitchen is one example, not everything is predictable or modelled. And knowledge is often applied using, as we can see, dynamic problem solving. This may be a situation where there is a measure of uncertainty and possibly time pressure. We tend to behave in ways that make sense to us and which we believe will achieve a desired outcome. If we succeed, we won't usually go back and re-examine our decisions. But if we fail, we may look back and see which decision led to that undesired outcome rather. This undesired outcome was unknown to us when we made the decision, and it may not have been predictable. Our journey towards success or failure is sometimes compared to traveling through a tunnel. Actions or decisions must be considered in context. In this case, what was the individual's perspective in that particular period of time? What was it that caused them to zig when they could have zagged? What caused them to turn right or left or proceed straight ahead? To learn their perspective, we must understand their mindset. What were their goals? This is the first step towards coupling their behavior and the situation. What we try to do is place that observed behavior back into the context that drove it and accompanied it. This tunnel depicts a meandering sequence that led to an outcome. The outside of the tunnel is what we see after the event, in the present, with that benefit of hindsight. This would be an investigator's initial perspective. In the present, we can see this entire sequence, all the triggering events, where we zigged or zagged, the outcome, points where decisions were made, erroneous actions, and the nature of the circumstances surrounding the route to trouble. The perspective of the person inside the tunnel, the person who was involved in the event, is a little different. From their perspective and their point of view, from within that unfolding situation, the outcome wasn't known. In the present, with that benefit of hindsight, we can see all of this. It feels, or can seem an orderly sequence, something that may have been predictable. They contributed to the sequence of events based on what they saw from within the unfolding situation. To understand what they saw back then, when they were involved in that situation, we need to attain their perspective. We learn to assess risks and make trade-offs. We kind of do this throughout our lives. In this picture, you can see an individual who certainly has a different attitude to risk than my own. I certainly wouldn't make any of the decisions that they seem to be about to make, or the decision they seem to be about to make. Within our systems, there are goal conflicts. The obvious one being the need to balance safety against operational requirements. The way we balance these goals may be in a conscious way or possibly subconsciously undertaken. Consider the situation. We're a low-cost airline. We need to get our aircraft out on time, very short turnaround. We're trying to maybe fix a defect. Do we complete the full procedure and the aircraft is delayed, or do we not? Perhaps a pilot on approach to an airport, their approach is unstable. Do they continue on, or do they go round and maybe arrive late? These types of decisions are influenced by our perception of the potential incentives and disincentives. These may not be the espoused values of the organization, that this is what we say rather than this is what we do, but maybe those which are rewarded. Sometimes these trade-offs can be driven by personal embarrassment, ridicule, or punishment. It's worth noting that we're all exposed to situations where trade-offs, production versus protection being the obvious one, sometimes seem like a viable form of behavior. Our performance is influenced and affected both positively and negatively by those around us. Team dynamics can lead to groupthink, where a desire for consensus or conformity can result in dysfunctional decisions, ineffective decisions, or perhaps the group might accept a greater risk above that which an individual may. It's not only negative in terms of what behaviors it can drive. It can operate in a positive sense, nurturing right behaviors and supporting effective decision making. The group and organization, which we belong to, establish the way we do things around here. And as I've already mentioned, this group pressure can be a powerful driver. It can lead to what's being described as the slow, steady uncoupling of local practice from written procedures. So in the image, we've got an arrow left to right, point A to point B, and we've got a system of processes and procedures that we apply to get us from the starting point to the end in an effective manner. The prescriptive way of doing things. This diagram is illustrating a phenomenon known as practical drift, where performance varies from the ideal. So illustrated, we've got hopefully what would be the ideal. And then we can start to see a gap has opened up to what's being described as normative behavior. The gap is the danger area. The International Civil Aviation Organization state that drift is inevitable. It's where actual performance varies from the ideal or design performance. This can arise because of a number of factors, unrealistic procedures being one of them. We need to prevent this drift in performance before it crosses that boundary between what's safe and unsafe. The existence of a gap between what's described as work as imagined, which would be that top horizontal line, imagined by the designers and management, and work as done, the normative behavior. This gap and its existence is kind of widely known and accepted. There's often a belief at the sharp end that deviation or drift away from procedure is the only way to achieve the output. if we did everything that we're supposed to, we'd never get the work done. Drift may be required by circumstances that weren't anticipated by the procedure's authors. If activities are being delivered in other ways to those prescriptive policies, to the design process and procedures, our barriers may not be as effective as intended. Popping onto the screen, we've got these rectangles with the red holes that represent our barriers, our defences, and all our barriers and defences are imperfect to some degree. But we can open these holes, we can create these holes when we don't follow the prescribed process and procedure, when we're in that work as done as opposed to work as imagined area. Pictured to kind of illustrate when this breaks down, when people are in this drift area, is a British Airways A319, which at takeoff on departure from Heathrow, it lost both sets of engine fan cowls. This was back in 2013, and drift certainly played a part. It certainly had a role in the events that led up to this failure. The aircraft also had an in-flight fire, which fortunately, when the aircraft returned to Heathrow, it was supposed to be travelling to Oslo, was quickly extinguished. What we need to do is treat people fairly, not rush to blame or punish, and considering the real world circumstances in which people find themselves. If we do this, it'll encourage greater openness and hopefully proactive reporting of hazards. If work is being delivered, if activities are being delivered outside process and procedure, our barriers designed to capture error to prevent failure may not be effective. And we need our people to tell us if our defences, if our barriers, our processes and procedures being some of them, aren't fit for purpose. I mean, in this picture, a sign we've seen, no doubt, keep off the grass. They obviously work, perhaps not. You could consider that a defence, if you like. But for an defence to be effective, we need a clear understanding of human behaviour. It's key to ensuring that these defences are as effective as they can be. Managing that human behaviour is problematic. We tend as humans to choose the easiest route. Sometimes people refer to this as a desire path. You can see that on the right there. You know, there are two paths, one straight ahead. That's how we did it before. More about that in a second. And another path. Maybe that other path was the prescriptive route. The paths we choose usually represent the shortest and most easily navigated route between point A to B, between an origin and a destination. So how do we get people to behave? To follow a prescriptive compliant path. Don't walk on the grass, or perhaps remind people to behave responsibility. Maybe we can give them a ticket, fine them. In the image on the right, we can instruct people to do the right thing or physically prevent them from doing the wrong thing. We've placed a physical barrier there, an effective barrier, you could describe it. Illustrated is how we do it now. People formerly chose that desire path, the easy way of getting from point A to point B, and now they're taking the path we want them to. Between these solutions, between asking people to do the right thing and ensuring that people do the right thing, physically preventing people from going in the wrong direction, designing human error out of systems. Between these solutions, there's a continuum of more or less effective interventions. To ensure we select the best and most appropriate, we must have a clear understanding of the behaviours that we're trying to address. As you can see on the screen, there's an image, a flowchart described as a behavioural analysis flowchart, which is exactly what it is. We've called it the flowchart analysis of investigation results, the FAIR system. If you want, you can kind of open this up and maybe follow along with me when I describe it. It's been evolving over many years. It's based on the experience of its many users, originally based on the work of Professor James Reason, and people in aviation and high hazard industries around the world use this system or tool. It's a system for ensuring that as far as is humanly possible, we bring objectivity and consistency to our understanding of an individual's behaviour. To achieve this understanding, and before we would go anywhere near this FAIR tool, before we attempted to employ it, we need to have conducted an effective human in the system type investigation. We need to understand what happened, what were the contributing factors, what were the goals. We need to understand all these elements before we get anywhere near attempting to try and classify their behaviour. Context is paramount when we're trying to characterize an individual's behavior. Without that, it's almost impossible. Over time, we've added additional tests to the system to improve its output. We have a test which I describe as the try to walk a mile in their shoes, in which, given the same situation, we try to understand how peers may have behaved. Quite a difficult thing to pull off, but a really worthwhile exercise. Has it happened before? Has it happened to one person 10 times or 10 people once? Is it an individual or a systemic problem or a combination? We refer to this as the routine test. With a better understanding of the behaviours involved in a realised event or near miss, we are better able to design or redesign our barriers and interventions to reduce the likelihood of recurrence. The first step in the system. This is quite a difficult question and quite a difficult test. Always bear in mind, before we can even attempt to ask these questions, and the responses are binary, we must have accomplished this effective investigation. If at any stage when we were using this system, we got to a point and we thought, oh, actually, I'm not sure, we need to go back and ask more questions. So was there a conscious and substantial and unjustifiable disregard for risk? Again, binary answers. The number of people who head in this direction is small. The number of people who have malicious intent, who consciously and substantially and unjustifiably disregard risk, certainly in aviation, is tiny. So we answer this question. If it's yes, sabotage or attempted sabotage. No, recklessness. It's not a route we often take, and that's a good thing. In terms of the test, if people haven't consciously, substantially, and unjustifiably disregarded risk, which is the majority of us, I think, we head towards the next key question. Did we intentionally break the rules? If I could see you, I'd ask you to put your hands up if you've never broken the rules in the workplace. Maybe you have your own thoughts if somebody did put their hand up and say, no, I've never broken the rules. Again, binary choices. If we didn't break the rules, we need to understand, was the action as intended? There's a difference between error and mistake. Again, understanding why people have behaved in a different way, and often we use mistake and error interchangeably as words, but they are different. In the case of an error, unintentional, we'll look at the person's performance, we'll look at the system. In the case of a mistake, it's usually a situation where somebody has possibly applied the wrong plan, maybe based on experience. We might look and consider addressing a training need. So in all of these cases, it's about pointing us in the direction of interventions. The violation question, were the rules intentionally broken? If the case is yes, again, this question is a difficult test. It can be a difficult test to pass. In the circumstances where all applicable rules and resources available, workable, and correct. In terms of getting past that, imagine the situations you've been in the past, the situations you've experienced. Have you always had all the elements of support you need? If the answer was no, was the situation at the time outside standard operations? Was it an unusual situation? If it's no, in that situation, we perceived it was a necessary evil to violate, to break the rules, to achieve the output. If the answer was yes, we're talking about really exceptional circumstances, sometimes emergency situations, where we deem it necessary to break a rule. The other route we can take at that point, where we ask the question, in the circumstances where all applicable rules and resources available, workable, and correct. If we go down the yes route, we can start to, again, break down, understand why people behaved in this particular way. In the vast majority of cases, when people break the rules, it is to benefit the organization. There are very few situations where that's not the case. It does happen, but those situations are few and far between. So was the intended action to benefit the organization? So we've broken the rules for organizational gain. Again, it's about pointing us towards particular types of intervention. In the case, for instance, where we're talking organizational gain, in those kinds of circumstances, again, it's about addressing, what is the missing support that we need to put in place. No, violation for personal gain. Again, this behavior is rare, unusual. I wanted to get away because, the football's on this evening and I want to get home, watch that, and to do that, I need to finish my job early. There are certain circumstances where we set people up to do that. I mean, I've certainly been in a situation where I've said to others, once you've done that, you can go. Doesn't really encourage the right behavior. With a clearer understanding of human behaviors, we can effectively shape the systems in which humans operate and better inform our controls and interventions, improve our defenses, make sure that our defenses are better fitted to the situation. This will help us reduce the opportunity for desired outcomes, for failure, and really this illustrates, I guess, the key point of this conversation today is that understanding the human, understanding the way that people behave is the key to a successful safety culture. Thanks very much for your time today and listening to what I have to say. And I'd be really happy now to answer any questions that you might have, if you have any.
Well, thank you very much for that, Marcus. It's a very, very thought-provoking presentation. I'd now like to go on to the attendee questions, which if I can just have a look at. Sorry, bear with me. I had it a minute ago. Let me just reset the point. Sorry, can I get it? Oh, okay, got it. Right. The first question, excuse me, it's from Antonio Cortes, of Eagleview Technologies, Director of Aviation Safety. Marcus, have you experienced a situation where poor morale in an organization directly contributed to a serious safety event?
I've certainly been involved in investigations where events occurred against a background of low morale. I think it's almost a chicken and egg type situation. You're in a situation where it's difficult to achieve the task safely and effectively. It can absolutely have an effect on morale. And I guess to an extent, the reverse is true. I've not seen it directly cause it, but I've certainly seen it play a role in leading to an event, a contributing factor in a serious outcome.
Thank you for that. The next question is from Manav Sharma of Indian Air Force. He's a flight surgeon. Isn't drift more of a rule rather than an exception?
Yeah, I would agree, Manav. Yeah, I think lack of drift is I would say that's a good way of describing it, is the exception. Yeah, it happens in all systems. I would completely agree with that.
Thank you. The next question is from Warner Vanderveer of KLM. He's the Program Manager, Safety Culture. There's a strong desire for judgment using this FAIR tool. In Safety 2, you only ask who has suffered, what are their needs, who is in a position to remedy those needs. What do you think about this way of thinking about just culture?
I think in terms of the desire for judgment, we really need to understand people's perspective. It's not about understanding or gaining an understanding of people's behaviour so that we can use any form of negative intervention to move their behaviour in a different direction or improve the circumstances in which they behave that way. It's purely about understanding what drove the behaviours, and then with a better understanding of behaviours, we can better design our interventions. Thinking about the just culture element, really, particularly as with my background as an investigator, if you don't have an effective just culture in an organisation where people are comfortable to report, highlight issues, and their concerns are taken seriously, they won't report. I certainly wouldn't do that against the background of perhaps being punished if I highlighted a mistake or an error or a violation that I'd been involved in. And certainly, going back to my experience as a safety investigator, You can't have effective investigations unless people believe that what you're trying to do is improve the situation, make their lives easier, essentially. Trust is absolutely key in all of this. Without that, this system won't work. Well, not so much this system won't work. You wouldn't be able to use it because you wouldn't have the information that you could deploy to use the FAIR tool to gain that structured understanding.
Thank you very much for that. The next question is from Jonathan Helliwell, Center for Process Innovation Operations Support Director. What is your opinion on the use of behavior standards in an organization?
I'm not 100% sure what you mean by that question, Jonathan, but I'll go with my interpretation. If we talk about professionalism within an organization and the appropriate standards of behavior, we have to set the scene and allow people to be able to behave in the right way. But this can only be done against the background of effective support. I would describe myself as a professional, but certainly in the past I've broken the rules, and I think in describing somebody as a professional doesn't necessarily mean they've always stayed within process. It's about the system that wraps around people that supports appropriate behavior. We want people to do the right thing. We need to support people to do the right thing to achieve the appropriate standards of behavior.
Thank you very much for that. Since we have gone through all the questions, I would like to use my privilege to ask the last question, please. I teach aircraft design, and one of the things I always tell students is go through all the air accident investigations and skins peeling off. One of the most terrifying experience for the pilots and the occupants of the aircraft must have been that instance where you pointed out the A319, the fan cowls had not been latched, and it took off. Could you just go through? I think that's a very good example of how things went wrong. Could you just quickly sort of elaborate on the sequence of events that led to that incident, and or I should say, and how the spectacular recovery afterwards?
Yes, certainly. The aircraft had some routine maintenance conducted on it, and and when these things usually occur, it's in the wee small hours, darkness. Most of British Airways maintenance takes place near and around Terminal 5, which is the BA terminal at Heathrow. In this particular case, they were involved in a routine process where they needed to check the level of a fluid in each engine. To do this, to gain access to check this, you needed to open up these large engine fan cowls. The locks for these hinged panels run underneath the engine, underneath the centre line. They're quite difficult to see, and unless they're left in the appropriate position, it can be difficult to tell whether the doors, the fan cowl doors, are properly locked or not. Involved in this particular event, there was a shortage of equipment for the people to conduct this task, so they had to go away and became involved in some other work. Eventually, when they returned to the aircraft, really unfortunately, the aircraft had been moved and another aircraft was in its place on the same stand. They went to the engines and they'd gone outside process and they'd left these fan cowls insecured. The rule at the time was you either left them locked and closed or open and clearly locked open with an entry on the documentation to illustrate that they were in this position, so that there was a requirement to certify closing them. They didn't pick up on the fact they were looking at a different aircraft, unfortunately. They couldn't understand why somebody else had closed and locked these fan cows, but they were able to rationalise it in a number of ways based on what was presented to them. So they took another look. The oil levels were now at a level that didn't require replenishment. Again, they rationalised this. They were looking at oil in the engine. They rationalised this, that, as the engines had cooled, the oil level had stabilised, in the green, if I can use that term, and no top-up was required. They closed up the fan cows and went away and certified. Early that morning, it was a bit of a rainy, miserable day, and on the stands at Heathrow, you've got CCTV, so some of this was captured. So it's a 2-crew flight deck on this particular mark of Airbus, a 319. So I guess as it was raining, they decided they'd send the first officer out, or the captain would send the first officer out to do a pre-flight inspection, essentially to walk around and make sure everything was in good condition. Now, one of the things they should do is get down and look under the engine and make sure these latches are closed, locked, properly engaged. But to do that, you need to kneel on the floor. And it was a bit of a wet, damp, miserable morning. This person had looked many, many times before, and there'd never been a problem. So on this occasion, their check wasn't as effective as it should have been. They didn't get down on the floor and take a look. There were a number of other issues, but I would recommend that people take a look at the AAIB website and take a look for British Airways A319, use a search term, something like that. And it's really well worth a read. The kind of human factors elements and some of the weaknesses in the system really, abound. Unfortunately, the aircraft then ended up in a position where the panels weren't closed and locked. And as it took off, you had the airflow over the engines. The fan cows opened. They were then ripped off by the airflow. They're large, heavy pieces of stuff, of composite material and metal. They caused some physical damage to the aircraft. And on the right-hand aircraft, they damaged some of the engine fuel system, which led to a fuel leak and subsequent fire. The crew did all the things they should have done in terms of responding to the emergency. One of the things they did was deploy the fire extinguisher, release the extinguishment. It wouldn't really have had much effect because usually it would be contained by those doors. So unfortunately, they were essentially trying to put the world out when they deployed the fire extinguisher. They got on the ground, the fire was still burning, and the Heathrow fire crews were on scene really, really quickly and managed to extinguish the fire almost immediately. There were 80 people on board, and all of them were able to leave the aircraft, and there were no injuries. So ultimately, the way the emergency was handled, we ended up with a kind of happy outcome, but it could have been different. And one of the things we talk about when we refer to this event, where we talk about human behavior and human error and failed barriers, this was that there had been more than 40 occurrences of these fan cows being essentially lost in flight or on takeoff. So this wasn't the first time. It happened many times before. And we talk about, were previous interventions successful? What should we be doing to understand why this is happening and, preventing further occurrences? Design and the human. Hopefully that's okay.
Absolutely, Marcus.
Yeah.
Thank you so much for a very detailed answer. And the best part of the whole incident was that no one was hurt, and
Oh,
some
absolutely,
very
yeah, incredible. Yeah, yeah, the crew did a great job. Sorry, I've just noticed there's a question from Ali. Would it be okay if I just
sorry,
respond?
yes, sorry, beg your pardon.
No.
I didn't. I just seen that. If I can just, yeah, thanks for the great presentation. Here's my question. I'm from Iran, and as we know, there are cultural differences between people in the world, around the world, and I wonder how these differences affect human behavior, and how should we deal with them in the process of understanding human behavior. Thanks again.
Yeah, thanks for that question. A really, really interesting one, Ali. Certainly in the flight crew world, on the flight deck, this is something, particularly with larger airlines where you've got multinational, many nationalities that operate the aircraft. So you can have people from all over the world of different ages, genders, national backgrounds, religions, all coming together to work in that combined, and kind of complex environment. And certainly to ensure that their relationship works effectively, they're effective system managers. This is taken into account. There are certain places in the world, for instance, where it's difficult for people to highlight their own failings because culturally, face and loss of face is a huge issue. And that's not to say that the individuals are bad people, but it's one example where national cultures certainly play a part, and it would feed into, whether we can have a successful just culture. And it's certainly the case in terms of the language that's used. English is for me as a native English speaker, fortunately, the language of aviation. But in terms of the language we use, the way we use language, tone of language, our national background, our heritage can play a part in that and can lead to misunderstanding. Simple things like hand gestures. Hand gesture in one part of the world, may indicate to us that everything's good, all is okay. In another part of the world, it could be an insult. Education, I guess, is the key, and the understanding of why we want people to respond to, I guess, the application of a just culture. But it's difficult to manage. It's difficult to manage when you've got a multinational group. It makes life really, really interesting, and from my experiences in the past, I've absolutely loved it. But education is the key, and ensuring that we understand, exactly what we're trying or aiming to achieve. Hopefully that makes some sense, Ali, and thanks very much for that question.
Thank you very much for that. My apologies to Ali Samani, who is a PhD student at Shiraz University. The reason is that I only saw the first line. I forgot to expand it, and I didn't realize that there was a question underneath. So sorry about that. Anyway, at this point in time, since we got 5 minutes, I just want to take this opportunity to wrap up this session by thanking Marcus Madden very much for a very thought-provoking presentation, especially when he started. I think all of us are very fortunate in being in this particular part of the profession, especially when he said, my passion and the profession are one and the same. So I think we are very, very fortunate to be there. I also was very interested in the behavior in this socio-technical environment. We are living in a more and more technological world, and how our behavior can be predicted, especially the decision making and the risk assessment, and the unjustifiable disregard for risk. And one of the sort of items that went through my mind was, of course, certain drivers who do not give due care and attention. Also, drifting away from the prescribed procedures, that's an interesting problem that happens all over the place. And what was particularly interesting to me was the behavioral analysis flowchart. That certainly, I never realized that there could be a difference between mistake and error. So that was made very, very clear. And of course, the most important aspect is perhaps trust that you place in your colleagues, your bosses. That is very, very important, especially in high-power industries such as aviation. There's so much at stake safety-wise. So all in all, absolutely splendid presentation and a very, very nice set of questions, which I think indicates the strong desire for to know more about how to cope with the human failings, if you like, and also train the next generation to ensure a safer operating environment for all concerned. So many, many thanks, Marcus, for a very, very nice lecture. And I would like to thank all others, the committee members, and all who. A lot of work goes behind the scenes. So, on behalf of the chairman, would like to thank all concerned. And I don't know which part of the world you're from, but I'd like to bid all of you a good afternoon from the United Kingdom. Thank you once again. Bye.
Thank you. Bye.
Thank you.